Well, good morning, everybody, and welcome to this new webinar, How to Use Pricing Optimization in a B2B Setting. I am Francisco Guanchi, and I am the Data Science Lead here at Dunn Solutions. And for today, the agenda is we're going to go through a brief introduction. We're going to talk about targeted pricing in a B2B setting. And then we're going to go through a case study, Jake's Cleaning Supplies, to see how we can optimize prices using predictive analytics in a B2B setting. So a little bit about us. Dunn Solutions is a digital commerce and business transformation consultancy. We have been around since 1988, and we have 3 offices. The main one here in Skokie, Illinois, and we have an office in Minneapolis and in Bangalore, India. Our business model is to deliver velocity to our clients, and you may remember back from your Physics 101 that velocity is really a combination of direction and speed, and we provide direction through our analytics services and speed to market by helping our clients automate their business process. Now, we refer to this process as the virtuous cycle of customer engagement. So basically, in addition to providing analytics and marketing automation solutions, we also help clients integrate them in their digital platform. Great. So now going back to the topic of the webinar, let's talk about machine learning in B2B settings. Now, the B2B setting or the sector is a huge part of the US economy, but it has been very slow at adopting predictive analytics. And I think there is a misconception there that because B2B transactions are so complex and the human component is really important, then predictive analytics is not as useful. But I take a completely different stand, and I argue that it is that very complexity that creates a lot of opportunities to leverage machine learning or predictive analytics. Now, one area of interest, which is also what we'll be talking about today, is dynamic targeted pricing, where the complexity really comes from having to simulate all the decisions that the buyer makes and how each decision has an impact on the very next one. So what is dynamic targeted pricing? Well, first of all, we need to understand that pricing decisions in B2B are much different from those in B2C. So for one, the seller can charge their customers different prices for the same product. For example, customer A might receive a completely different price for product A than customer B does for the same product. And also the seller can usually change the price with little or no notice. So obviously, this kind of price discrimination, which by the way would be impossible in a B2C context, creates tons of opportunity to make a quick profit in the short term. However, it can also negatively impact the relationship that the seller has with the buyer and affect the long-term profit. So if you want to use machine learning for pricing decisions in B2B, you need to make sure that you design or that you use a methodology that accurately predicts not only the short term, but also the long-term effect of your pricing decisions. So in the next part of this presentation, we will present a case study to show how we created such a methodology using transactional data from one of our B2B clients. Now, before we do that, there are a few concepts that we should be familiar with if we want to use machine learning in a B2B setting. First, is the business selling commodities or manufactured goods? And that's a big difference. And the reason is that commodities are usually homogeneous in nature, and what that means is that they tend to be more price sensitive. So let's say that you are a B2B retailer of lumber. Well, lumber offers little to no differentiation, so your buyers will pay more attention to the prices of your competitors. Now, the other thing that we have to be familiar with is external reference price. Now, this is more important if you sell commodities. But again, the price of commodities is really available, it's easily available. and your buyers can easily reference to it and determine if they're getting a good deal. Now, the next important one is the internal reference price. Now, this is the individual specific price that your buyers or your buyer has paid in the past. So buyers tend to reference to the price that they were charged in the previous transaction or previous transactions to determine if they're getting a good deal. So they'll look at the previous transaction and what they paid, or maybe the couple of transactions before this one, and see if they feel that they're getting a good deal. And finally, we have to understand that the effect of a price increase is not necessarily proportional to the effect of a price decrease. And what I mean by this is that, let's say that you lower your price by 1%, and by doing that, you increase your sales by 2%. Well, that doesn't mean that increasing the price by 1% will also decrease your sales by 2%. The effect of price changes are not symmetric for price gains and price losses. Now, the other things that we have to consider are the risk of implementing a pricing strategy. So what is the probability that our customer is going to churn, so it's going to leave us as a result of a price change? So risk is another important factor we should take into account. We should understand the latent customer state. So we can't really observe it, but we should have a way of measuring the state of mind of our customers at any given point. So how much they trust the relationship, how they value the relationship with us. And finally, we have to understand that the results of one or more models, so the output of one model really becomes the output for the next model, and that's how you simulate that decision process that the buyer goes through. So with all that being said, let's move on to our case study, Jake's Cleaning Supplies. So with all the pricing decisions made by the salespeople's best judgment, is Jake's really optimizing long-term profits? So let me tell you a little bit about this client of ours. Jake's is a B2B manufacturer and distributor of industrial cleaning supplies, and they have sales of approximately $30 million per year. Now, they have roughly 1,800 customers, and every customer has a unique pricing list. So technically, there could be 1,800 different prices for the same product. Now, all prices originally, they were set and modified by Jake's salespeople, and they used a subjective approach. Now, subjective doesn't mean out of the air, right? It's based on factors such as knowledge of the client, duration of the relationship, persuasion skills, and so forth. Now, Jake's has the ability to change the price. However, they have an agreement with their customers that they have to give a 30 to 90 days notice. So the key question is really, how do we know at this point that we're really charging the right prices? Can we develop a more scientific approach so that we can ensure long-term maximum profits? And that's why they came to us. So we proposed this kind of approach. The name of the methodology is not as important. It's hierarchical vision, integrated, and that's fine. But really, what it comes down to, it's a series of 3 models. One that model simulates the change in quantity that a buyer purchases due to a price increase or decrease. Then we use that output for the next decision that we have to simulate, which is the change in frequency of the number of purchases due to that to a price change, right? And finally, we have to simulate the risk of attrition. So what is the risk that a customer will stop purchasing our products as a result of a price change? After we have these, we calculate all the weight, we calculate all these inputs, What we do is to calculate our expected margin, so how much we think we're going to make this year if we don't change anything. Then what we can do, we can put all these inputs in an optimizer, and we can see, okay, what is the right price that maybe I should try and charge to make more margin, to make the optimal amount. And then what we can do, we can divide the population, our customers, into two groups. One is the test group and one the control group. In the test group, we'll use our optimized prices, and in the control group, we will not change the prices, and we will test them over time and see which one is outperforming the other one, and if we are right in our assumptions. Now, before we can jump into modeling, there were a few things that we had to do and that we have to be aware of. So we have to make sure that we model the correct dimension. And the dimension, we call it the subject. The subject is really a unique combination of unique customer ID and product. And the reason why we have to model at this level is because every customer can have a different price for every product. So we can't escape that. There's no other dimension we can model at. We cannot model at the customer level, and we cannot model at the product level. We have to model at this combination of customer and product. Now, that being said, there might be some combinations that don't have enough data to create this model, right? So maybe there's no historical price variation for a specific combination of customer and product, or maybe it's a new product or it's a new customer. What it comes down to is that we don't have enough data to model it. So what we do is we cluster all the subjects into lookalike groups or clusters, and we use the clusters whenever we don't have enough information on the specific subject. So if we have to borrow information, we will get the information from the cluster, from other subjects that look alike the one that we're trying to model. So what do we see about this specific business? Well, the first thing that we saw is that the quantity that people buy increases or decreases only 0.9% for every 1% increase in reference price, but it only increases only 0.24% for every 1% decrease in reference price. So basically what we're saying is that demand for this product is not really elastic, meaning that a 1% increase does not change quantity proportionally. However, it's even less so for when you give a price discount than when you give a price increase. Just to put everything in perspective, if you were to give a 10% discount across the board, you would expect to make 2.4% in additional profit, which is not really that great, right? And if you were to increase the price by roughly 10%, then you would lose about 9% of the volume. That's what we mean. We also noticed that the impact is seen across multiple purchases. So it's not just the very next purchase after a price change, it's also the next roughly 5 to 6 purchases that may be impacted by what we call a price shock. Now, we did say that lowering the price, so giving a discount by 10% would only increase quantity by 2.4%. So it's not really that much. It's a little bit, but not that much. However, we also found that even if you are able to increase quantity, the time in between purchases increases substantially. For every 1% increase in quantity purchased at this time, the repurchase time increases by 7%. So let me put this one in perspective. Again, if you were to somehow be able to increase the purchase that your buyer, your client purchases at any given time by 5%, that client would not come back, and the time to the next repurchase would increase by an additional 49 days. So this means that for this specific client, you would go from 3 expected orders per year to 2. So you can see that in this very case, lowering the price is not a good strategy to increase profit. So you might be tempted to say, so why don't you just raise the price? Well, raising the price comes with the risk of losing the customer. So you can see that in here, we observed a price increase of roughly 6% in January 2019. Now, up to that point, you can see that the number of subjects that disengage with us, that don't buy from us at any given month, is roughly 28. But as soon as we announced the price, that there was going to be a price change, and we have to announce it 30 to 90 days in advance, you can see how the number of people that decided not to buy from us anymore increased by 62%. So it went from 1% to 1.7%. So even though increasing the price seems like a good strategy in the short term, you have to make sure that you can calculate, or you have a good estimate of how that is going to raise the risk of attrition, customer attrition, before you can actually stimulate your long-term profit. So with all of this being said, all these models calculated a set of weights. Now, I'm presenting them to you aggregated by cluster because obviously I cannot show 33,000 different weights. So this is a much better way of visualizing it. And how do we use them? Well, we just use them to simulate the margin formula. So the margin formula says that margin is really a function of future revenue from newly acquired customers, which we can't do anything about. Now, increase or decrease in future revenue from retained customers. Then we have the future revenue that will no longer happen because we lost some customers. And then we have to subtract the cost of goods sold. Now, the quantity elasticity gains, the quantity elasticity losses, the inner purchase time, and the risk elasticity, these are all inputs that have to go into this formula to calculate our expected margin for this year. Now, once we've done that, how do we calculate the optimal prices that would maximize our margins? Well, that's when you put everything in the simulator. And what the simulator does is that it takes all these weights, it creates this formula, then it starts from the current price of a given item for a given customers and goes like this. The item is selling for this specific customer at $47.47. And based on all the weights and all the formula, at that price, we're making roughly $3,082 in profit. Now, what would happen if I were to decrease the price by 1%? Well, you can see that if you decrease the price, the profit that we forecast, that we predict, that the model predicts, is less than the profit that we were making at the original price. So the optimizer stops immediately and starts going in the opposite direction. Now we start increasing the price, and you can see that the profit gets bigger and bigger and bigger until you get to $50.89. And then when you move from $50.89 to $51, then the profit starts going down again. So we call this one the optimal price, which is really the peak of the curve, as you can see right here. So in this very case, for cluster 8, and remember, we do everything at the subject level, but once again, I'm presenting it at the cluster aggregated by cluster so that we can visualize it. For this specific cluster, we would say if you raise your average selling price by 9%, so if you go from 47 to roughly 51, then you will increase your margin by roughly 2.9%. So this is the kind of recommendation that we would give to a client and that we gave to this specific client for this specific case study. So how did we do it? So we delivered all the optimal prices, the clients implemented them, and they implemented them for a test group and for a control group. And then we tracked them over time and see what the performance, and we saw what the performance was. Now, in the test group, we saw that for the first 4 months of this experiment, the test group will always outperformed the control group by roughly 11%. Now, it's not always 11%. The first month was 11, the second was 14, then again 14, then it went down a little bit. But generally speaking, we're seeing that we were correct. The optimal pricing are making more money for this company. Now, with that being said, I do not suggest in any way that pricing or the modeling or the machine learning should or even can replace the salesperson. That's not the point I was trying to make. Instead, I do see it as a tool to equip the salesperson with, and that can generate more profits or profits significantly higher than the salesperson alone can. But we've also seen that creating robust pricing models is really challenging. So please don't hesitate to contact us for a free of charge assessment of your data, and we will gladly tell you if and how you can leverage your data to increase your profit. So for now, I want to thank you all for your attention, and I hope to see you for the next webinar.